So today I thought I would just kind of talk to you a little bit about kind of the smallest piece of this. We're always talking about big data and all the really big things we're going to do. I'm going to kind of drill down to kind of what's going on inside that mobile phone that we're all kind of carrying around in our pockets these days that serves as that very first source of where that location information comes from. So how we tag all that sensor data and all the other data with an actual location. And I want to talk about some of the progression that's going on in that space. So you might first ask yourself, you know, what's Intel doing in this space? Why are we here? So we're very much a technology company around, and you think of us as purely a PC company, but we've really kind of evolved over time into more about connecting devices, people, and data. And our businesses have grown from kind of the traditional PC, which is now kind of sitting in the middle, and moving all the way up into the data center side on one end and all the way down into the wearables and IoT side on the other. Because fundamentally all these devices need to compute, they all need to connect, and that's the kind of technology at Intel from a Moore's Law perspective that we can use to make those devices cheaper, lower power, and get out into everyone's hands and all over the world. So when we look at location and how that fits into that methodology into our business, this is kind of where I kind of intersect with the Intel folks, right? So we're trying to figure out how do we make sure that we have that location capability available all the time, 24/7, right? Where does that flow into the different product lines and the different capabilities? One of the things I'll talk about a little bit today is I think we're all really familiar with kind of the outdoor location side, but I also want to talk about the fact that most of us spend 80 or 90% of our time indoors, and that's a big location hole in terms of where people are and where that data is being consumed. So we're going to talk a little bit about some of the technologies that are evolving in terms of being able to maintain your location indoors. And then we're going to talk, not very much today, but it's another big area around how does that location interact with security and privacy when everybody's walking around with a mobile phone and everybody has access to that data, but is also providing data in the forms of Google Maps or other places where the information that you're providing about the speed that you're traveling at that particular time at that particular location is very important to everybody else. But how does that data maintain its security and its privacy? So those are kind of the areas that we look at. Today I'm going to focus a little bit today on the middle one. I don't know if that's exactly what you guys are interested in, but it's the first time coming to a place like this, so hopefully I hit the mark in the middle. So this idea of being located all the time is something that I think we're all getting used to. Like I said, I think my kids are more used to it than everybody else. And I know in my family we use an application called Life 360, which I don't know if any of you know that application. Anybody ever heard of it? Life 360. So 50 million families use this. It's a location tracking technology, but it's an opt-in kind of individual location. So at any time I can just pick up my phone and see where my kids are, which is kind of nice because then I tell them you can go wherever you want as long as you have your phone. And I don't need to keep kind of texting them all the time about where they are or where they're going to their friends' houses. So it's really become, and they don't mind it. They don't look at it as an intrusion in their lives. It gives them more freedom and more capability. So I think there's a generational perspective that's really different. A lot of us don't like that idea, but other people don't find it as intrusive. So we're going to look at kind of all those different capabilities that are flowing into that in 10 minutes or whatever I have left. So this is the way that smartphones work. So the way smartphones work is we sit down here at the bottom with all these different sensors. So the ones on the right here are your standard kind of MEMS, mechanical sensors, accelerometers, gyros, magnetometers that'll tell you about motion and where you are from a movement perspective, as well as things like GNSS, Wi-Fi, Bluetooth, and cellular, which are point positioning technology. And that'll kind of tell you where you are in a larger context. And if we move up from that layer of the actual hardware components, we move into this ability to want to create a location engine inside your device at the chip level that's going to bring all those together. And there's a lot of hardware continuity that has to go on there. The thing that I think most of us are used to is what sits all the way at the top, which is these applications at the top that are the kinds of applications I talked about, and then the services that sit off on the side And then we have these location engines that are running at the application level that are controlled by the operating systems, by the Googles and the Apples of the world, that allow everybody on the outside to have wider access to this capability. But there's a bunch of layers underneath. So what do we do with that, right? We take that and we turn it into indoor and outdoor navigation. We look at scheduling of devices, how this integrates with your calendar, right? The device localization, you want your phone potentially to act differently when it's at home than when it's at work. You want to be able to kind of keep track of where you're going, to do this logging and digital storytelling, a lot of this social networking things that are coming up. We're supporting kind of the shopping and advertising and gaming methodologies that are all location-based, and then all the way down to this other thing of rights management, which is once we create a lot of this data, we don't necessarily want, or people, enterprises in particular, don't want that data being accessed all the time. As workers get more and more mobile, then the control of the data and the access methodologies into the data is no longer just about having a VPN, but the data itself might be location sensitive. They might only want it to be accessed in secure areas, might not want you working on the corporate financial spreadsheets when you're sitting at Starbucks. So there's a bunch of data and location management applications that are going on at all different levels inside. And each of these models kind of has a different accuracy requirement. Depending upon what you want to do, you might need a very different level of accuracy if you're trying to find a product on a shelf versus if you're trying to get somebody to come to your store. So we look at kind of this overall methodology, and we try to find the right technologies that are going to provide both the right level of accuracy as well as the right level of power consumption of your device in order to maintain that kind of accuracy. So these are the technologies that we use, right? And what we want is something that's really, really accurate that we can use all the time. That would be great. There isn't any such single technology here, otherwise I wouldn't have a job, so it's really good that there's not a simple, easy answer. But you know, we started out in phones with using cell towers, right? You know, which was pretty good from a generic standpoint. We used this early on, especially in E911. To be able to, when you make a 911 phone call, to make sure that we could route that call to the right public safety answering point, right? It was a big part of the E911 initiative initially. And now we started moving into more things around Wi-Fi, around when we go indoors and we're looking for both either the signal levels that we're seeing from different Wi-Fi access points, or all the way down to trying to look at fingerprints. In other words, there's a particular set of Wi-Fi access points that you might be seeing that would create a fingerprint of where you are. But the problem with that is, as you can see on this chart, it's very low on the availability scale, because somebody has to go through and map all that, has to create all that, even though it creates a very accurate fingerprint. And then we've also been hearing a lot lately about Bluetooth Low Energy, about this beaconing technology, right? The idea that we're going to place beacons in a lot of different places, and you'll be able to just associate your location from a local beacon. Again, kind of a very accurate methodology that requires an awful lot of infrastructure. And then we also have these inertial sensors that are in our phones, which turns out they work all the time. Right? They're always available there to try to do things like pedestrian dead reckoning, right? We can actually navigate while you walk, as you're all used to from all the Fitbits and the joggers and everything else work this way. But they're not really very, they have a very wide range of accuracy. Some of them are really good, some of them are not so good. They tend to degrade over time, and they're not really very, very useful for doing some of what we want to do. We have NFC technologies that we use, right? Near field communications that are very focused on enterprise solutions and corporations. And I'm going to talk a little bit about a new solution that's coming about called Fine Time Measurement, or FTM. And that's one of the places where we're looking to see something really interesting and new that might help in a bunch of different areas. And then what we're actually going to do at a company like Intel is we're going to take all these things together and try to bring them all together, because all those sensors, all those communication technologies is all built into your phone or your tablet or your PC, which is giving you the access to the big data that you want to get the information that you're looking for, but try to bring the location together from all those different hardware pieces, so that you as the application provider only have to ask one question, right? Where am I? You don't really care where it comes from. All you want to know is, where is it, how accurate is it? So this idea of fine time measurement is something that's coming about now, that's related to the same way that we do GNSS, but trying to do it over Wi-Fi. So what we're doing is we're going to measure the distance between you and a Wi-Fi access point. So assuming that you have Wi-Fi coverage and we know where the Wi-Fi access point is, then it's a very simple, not a very simple, it's actually a relatively complicated methodology to determine that distance from a radio propagation standpoint of where you are relative to the access point. So we're going to kind of ping the access point, it's going to reply with a message, and we're going to take out the timing errors that are associated inside to determine your actual location. From this, we're actually going to use Wi-Fi access points in the same way that we use GPS satellites indoors. So this gives us the potential now to provide kind of continuous accuracy from an indoor perspective as well as an outdoor to determine where people are, where resources are being used, and what data potentially is being accessed in different places. So this is a really exciting thing. It's coming. It's a technology we can demonstrate today that's being standardized in the alphabet soup of 802.11, which is our what we do with Wi-Fi. This is actually called 802.11mc. So it'll give you an idea of how many different standards within the Wi-Fi world there are. So this is something that's going to present us the ability to provide another level of accurate location where we're now going to be able to provide indoor location as accurately as we provide outdoor location. So this idea of 24-hour, 7-day-a-week ubiquitous location is going to be coming to your device in the not too distant future. And this is the kind of results we get out of using that kind of technology. If you look here, this is an area inside an Intel building. The little dots are where the Wi-Fi access points are. The little blue dots are the path that was traced by people using these devices. And the purple is kind of the truth line. But what you see as a result of it is that we're able to maintain something between 2 and 3 meter accuracy 90% of the time. So we really believe that this technology, like most things we do at Intel, we're the technology people. We build this stuff into the chips and we put it out there and we let all the really smart people in the world figure out what to do with it. So we're just trying to enable this new level of technology around location, both indoor and outdoors, around big data, IoT, wearables, and make sure that the location piece of the question is available all the time for whatever it is that you want to do with it. So thanks a lot, and I hope to hear all your great ideas of what you're going to do with what we're doing.